Hey guys, Mr.Enyart here. As you know, I'm a huge sports fan, and there's no sport I love more than baseball. I love baseball because I can use statistics and percentages to help me improve. They track everything in baseball, and the more I understand the mathematical language behind what the statistics mean, what is my on-base percentage, and what does that mean? What's my batting average? What does that mean? How often do I swing at first pitch strikes or take first pitch strikes? How can I use those percentages and decimals to better improve myself in baseball? Today I want to talk with you about how we can use math to help us in other areas, starting with percentages, fractions, and decimals. So let's start with the definition. A percentage is the amount of identified pieces out of 100 total pieces. So that means a few things. To be a percent, you must have 100 total pieces. So it's out of 100, or at least it's based on our base 10 system, which has hundredths in order to make a whole. So as we see here, this model has 100 pieces to make up the whole, and I have 1, 2, 3, 4 of them that are yellow. I can represent that as a fraction as 4 of 100, or we would say that 4 hundredths. And since a percentage is the amount of identified pieces, 4, out of 100 total, so it has to be out of 100, there's 4 of 100, I can simply write my percentage as 4%. And we use this symbol to represent percent. Now, obviously, I can go through and rewrite my ratio. My ratio here would simply be 4 to 100. And as a decimal, I would write it as 4 hundredths, the fraction. So again, as I'm looking here, I hope you remember from earlier, maybe 5th grade or 4th grade, when we started writing this, these are what we call hundredths. These are worth 0.01, 0.01, 0.02, 0.03, 0.04. So I will write that as 0 wholes, decimal, 0 tenths, 4 hundredths. And I say that as 4 hundredths. Now, you'll notice these next ones, which will be challenges, do not have 100 as the denominator. They do not have a total of 100 pieces as the definition says for a percentage. My question is, what should we do in order to write a percentage, knowing that percentages have to have 100 total pieces? I want you to pause the video and try to fill out the rest of this table on your own. Feel free to color in on the this on your screen if you've got this saved and explained everything or Notability, or feel free to write this on a piece of paper and make one of these on your own. After you're done, replay the video and compare your answers to mine. Then pause it and see if there are any differences, and if so, what mistakes were made. Go ahead and pause the video now. Okay, so now it's time to compare. When we look at 3/10, the way to get it to a percentage is to change the fraction into a denominator, an equivalent fraction that has 100 as the denominator. So we see when we change from fraction to ratios, we just rewrite it. The numerator is the first number, the denominator is the second. So what I showed here is I just want to make an equivalent ratio or fraction where 100 is my total pieces, and therefore, since 10 times 10 is 100, 3 times 10 is 30. So it's 30 of 100, which is 30% represented by the purple here. Written as 0.3 or 3/10, because 30 hundredths would equal 3/10. 1/4, again, what I did was rewrite it as with a denominator or a second part of the ratio, the total of 100. 4 times 25 is 100, so 1 times 25 gives me 25, and 25 of 100 is my percentage demonstrated by the red, and I write 25% as 0.25, where we say that 25 hundredths. And then we have 1 and 1 of 20, or 1/20ths, which of course would, in order to become 100, is times 5. So 1 times 5 is 5. So there are 5 pieces out of 100, which makes my percentage 5%, not 50%, but 5. And that's like 5 pennies, so that's 5 hundredths. So I write the 5 in the hundredths place, leaving me a 0 in the tenths place, represented by the green here. Now I still have quite a bit of blank space, and I can go 10, 20, 30, 31, 32, 33, 34, 35, 36. So I could say that of my unfilled space that's not shaded, I have 36% not shaded. And that's 36 of 100, or 0.36. And so here I've added the equivalent fraction so you can see how that and the ratios are related. But the most important part is the percentage from the fraction does not match what the numerator is unless the denominator is 100. So please remember the percentage is the amount of identified pieces out of 100 total. So let's just try a couple quick examples. Here Sam says 50% of the vehicles are cars. So as you can see, we have, just by observing, 1, 2, 3, 4, 5 vehicles. And so it might be helpful to write down that we have 5 vehicles. Forgive the handwriting. And we want to give 3 different reasons or models that prove or disprove. Let's say yes or no to Sam's statement. And models can include tape diagrams, 10 by 10 grids, double number lines, etc. So what can we draw? We have quite a few options here. If we start with a tape diagram, then we can draw out the model like this, divide it into 5 equal pieces, because if we're going to deal with fractions or equal or smaller amounts, we're dealing with equal pieces. And then of course we can just say that these are cars, and then these are trucks. Is that 50%? And I would show that that is 3 of 5, or 3/5 cars. And 3/5 actually transfers 2.6, or 60%. Therefore, it is not 50% cars. And that makes sense too if we draw another model like a number line. So a number line would look like this. And I'm just going to draw it, small and in that, and I'm cutting it off. And this would be 0, and this would be 5. And if I divide it into 5 equal pieces, so 1, 2, 3, 4, now I have 5 pieces. And I mark where 3/5 would be right here. I can see that that is well beyond half. Because if I were to say 50%, then that is me stating that half, right, 50% equals half, right? It equals 50 of 100. It equals 5/10. That's what 50% is. And I don't have half. And I can't have half because there's 5. I'd have to have half a car. If they sawed one of these cars in half and then got rid of it, sure, maybe I could say that, 2.5 cars to 2 trucks. Well, that still wouldn't work. I'd have to add a half a truck. So it can't be 50% because it's not even on both sides. And to say it's 50%, it would have to be even on both sides. I'd have to have a third truck over here, or I'd have to get rid of one of the cars, because 2 out of 4 is 50%. That's 1/2. What do you think? Again, I always encourage you to pause the video and try to work these out on your own first and see if you can solve for them. And then if you can't, or if you can and you want to compare, then play the rest of these. So again, feel free to pause this and any part of this to work ahead on the lesson 25 practice. So this problem I like because it gives us the amount of participants that are unhappy, and then it gives us the amount of participants who were happy. And it wants us to give a part to whole, not part to part. So notice both of these, this is a part of my total participants, and this is a part of my total participants, which means to find the whole, I have to add my two parts. So part one, we'll call them unhappy, right? That's 300. Part two, we'll call them happy. That's 700. How many total is that? I have to add them together. That's 1,000 total participants. Okay, this is my total participants. This is my whole. So I need to remember that as I write this fraction. See now, if you didn't know what to do first, now try and pause the video and try it. All right, so let's jump in. The fraction, of course, of happy is going to be 700. I'm going to zoom way in here, make this a little easier. It's going to be 700 over 1,000. And if you remember our rules that we can divide by 10, right? Because we need to make this out of 100. So that would just mean getting rid of this 0 and getting rid of this 0, which gives my new total to be 70 of 100. So now I can write my percentage. My percent is 70%. Because remember, a percent is an amount of identified objects out of 100. So the unhappy, obviously, you can just keep this going here. Unhappy is going to be 300 of 1,000, which again, I'm just going to divide and make it equal to a certain amount of hundredths, which means get rid of that 0 and get rid of that 0, right? Both of them divided by 10. So to move from here to here, I'm dividing by 10. So to move from here to here, I also have to divide by 10. So that's 30 hundredths. So my percentage is, ding, 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 30%. And if you think about part to whole, shouldn't 70% and 30% equal 100%, all the participants? Of all the participants, some are happy, some are not happy. And we could create a model, and I'm going to let you handle that part. But I do want to go into Renita. Let's check out Renita. She claims that a score of 80% means that she answered 4 out of 5 of the problems correctly. She drew the following picture to support her claim. Is she correct? Why or why not? Well, again, I encourage you, pause it, see if you can figure it out, and then move on. So let's jump into it now. So she's saying 4/5 is equivalent to 80%. So there's a couple ways I can do this. One is to go with what we've learned about changing this fraction into a denominator, into an equivalent fraction, where the denominator is 100. So how do you get from 5 to 100? That's times 20. So what do you have to do to the 4? Times 20. And 4 times 20 is 80. Good job. Now, is 80 out of 100 the same as 80%? Yes, it is. So far, I'm going to say yes, she's correct. I'm going to say yes, and then I'm going to use that as my explanation. But now let's check out her model here. She has done 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 across and 5 up and down. So if it's 20 across and it's 5 up and down, right, and I multiply that because this is basically an array, I have a total of 100 pieces. Which means that every time she fills in an entire row, that's 20 or 1/5, 1, 2, 3, 4, 5, right? This is 1/5 of her total. So if you just were to erase all of these lines in your head, and this was just 1, 2, 3, 4, and made that 5 pieces, 5 rows, and you filled in 4 of them, like so, that is 4/5 of the total. So her picture's correct, her numbers are correct, she's absolutely correct. And I bet if you stuck 4 divided by 5 into a calculator, I bet you're going to get 80%, or 0.8, 8/10, 80/100. Go for it, see what happens. And of course, on your practice, how else could you draw this picture? Could you make it more of a square and make it out of 100? So, I mean, that's kind of fun to be able to think about it that way. You know, oddly enough, we could use, for the exercise 2 here, we could use this model to represent what she was saying in the previous question, that 80% is the same as 4/5. So what I see here is I see a whole represented by the bar, and it's broken into 5 equal pieces represented by the 5 equal pieces. And so this would be 20, 40, 60, 80, 100. And that's how they're getting the percentages. So 80% is what fraction? Well, isn't this at the 4th of 5th of 5 places? So I would say 80% is at 4/5. And of course, I could then also say that that's 80 100ths. And I guarantee you it's right. 5 to 100 is times 20. And 4 to 80 is also times 20. So this is an equivalent fraction. 1/5 is what percent? So this would be where 1/5 is, right? And so I would just write 20%. And that makes sense because 1/5 is equivalent to how many hundredths? Yep, 20. So that was times 20, and this is times 20. And then lastly, we have 50%. Oh, not lastly, we have 2 more. 50% is what fraction of the whole quantity. Now check this out. There is no 50%, right? 50% is half. 50% would be like right here. I would say this is 50%, which is between 2 and 3. So that's like what, 2.5? But remember, I can always rewrite that percentage out of 100. So I can write it as a fraction. So there's a couple options. I could write 50 of 100, but according to the model, it's broken into fifths. So I would have to say that that is 2.5 or 2.5 of 5 total pieces. Because the bottom line is my top number should be half of my bottom number, and my bottom number should be twice as my top number to be 50% or 1/2. 1 is what percent of the whole quantity. Now this is, notice this right here, this is a whole. This is not 1/2 or one small amount. This is one whole. So if I filled in, I'm going to come back up here and use this. If I came here and I filled in the whole thing, right? 1, not 1 of 5. Okay, that is not this. This is 1 of 5. This is 1/5. This is not 1. 1 is a whole. What percentage? 1 is what percent of the whole quantity? I would say that would be 100%. And I can demonstrate that also by using the, if I want to do one whole, and I've broken it into 5 pieces, wouldn't that be 5 out of 5 pieces gets me here? And isn't 5/5 equal to 1? That's how I'd have to write it. And therefore, 1 whole is 100 hundredths. And 100 hundredths is equal to 1, because that's the same as 5/5, right? This is just an equivalent fraction, and this is times 20 and times 20. So out of 100, because a percentage is how many pieces you identify out of 100, the denominator has to be 100, has to be 100, has to be 100. That's how I get my 100% 1 whole. So if I get every single question correct on a test, okay, let's say there's 8 questions on a test, all right? Out of 8, you got all 8 correct. What percentage is that? Yeah, that's right. That's 100%. That means you didn't miss any. You get 100%, which of course would be an A+. Yay! And you get a smiley face. And they'd stick their tongue out at you, and you get the little eyebrows, right? Yay! Maybe get a little sticker with a star. It's a good looking star. Okay, and for the sake of you doing the work yourself, I want you to try 3, exercise 4, and the rest of the problem set on your own, and then you can come back and compare it to this, but I'm not even going to talk about them yet. If you have any questions, feel free to, while you're in class, work on it, ask your teacher, ask each other, and just compare it back to the previous things we talked about. So I'll put the answers on here in just a few seconds. I hope you enjoyed the lesson, and I hope the 25 exit ticket is easy for you because you've worked hard to understand the information. So here you have the answers. Pause it and compare it to yours. Hopefully you're doing this first on your own. Remember how to be accountable. This one down here may be a little tricky for you to see, but I wanted to show you my division. Obviously you could just do 5 divided by 8 in a calculator, and you'd get 0.625, but I wanted to show you how to do it here. But here's the only one I want to spend time on, because this is the trick. If you have a decimal, like 0.625 or 625 thousandths, and you want to get to a percentage, because a percentage is usually a whole number, or at least tens and ones, and then you may have more, because this has 3 decimal places, goes to the thousandths. All you ever do is multiply by 100. You move the decimal place 2 places to the right, and you get your percentage. So now you can get on here and you can write that it is 62.5% because you have 625 thousandths. You multiply that by 100, move your decimal place to the right 2 times because there's 2 zeros, and you get 62.5%. Again, pause the video, fill this out on your own, and then compare it. So you can see that I filled out the chart. Go ahead and compare, pause the video and compare yours to mine. And then I made a model for the first row. So thanks for sticking with me with percentages, fractions, and decimals. I know it may have been a little long, but I really hope you are understanding how I use the mathematical language of hundredths and how I can multiply and divide by hundreds to move from percentages to decimals, and then how I find like denominators, or equivalent fractions or equivalent ratios where the denominator is 100 in order to find percentages, and I can use them for all kinds of things. I hope you had fun, and if you have any other examples or things you'd like to share, please go ahead and add it to this video at the bottom. Subscribe, click, whatever you want to do, and keep coming back. Let's keep rocking out this math work. Have a good day.